Good morning, everyone.
Good morning.
Good morning.
Morning.
Any quick questions, or we're just waiting until 11? All right. There it is again one more time because it is 11 o'clock. So I'm going to go ahead and activate the daily quiz for today. So it's not a long word problem, but it's the same type of problem that we were solving last Wednesday, or on Monday, where you have an implicit equation, you take the derivative with respect to x on both sides, and you're given some information. Okay. So, I want you to solve that for me. Tell me what the change in y is over change in x when x is 2 and the y is 3. We'll share it. So there's the question. What is, consider the implicit equation for x squared minus y cubed equals negative 11. Want to find what dy over dx is when x is 2 and y is 3. I'll give you all a few minutes to do it. You just find dy over dx, the value of dy over dx when x is 2 and y is 3. All right, I'm going to give y'all, let's see, minute and a half. So 11:05 is when we're going to lock the answers. That is a minute and a half from exactly right now. So make sure you type in your answer, check your work. Make sure you don't have a small arithmetic mistake. Make sure you actually solved it. All right, you have 1 minute left. 1 minute left. All right, 15 seconds left. We've got most everyone in. 15 seconds left. Got most everyone responding. Let's see, we got 24 today. Ooh, we're missing a lot of people. So we're missing 2 responses. So you've got 5 seconds to hit enter. 4, 3, 2, 1. Locking answers now. Even gave a pause, try to help out. All right, so based on the answers, most of y'all are in the ballpark. A couple people gave me the implicit equation, didn't plug in x and y, which was kind of what was asked, but you at least got the right implicit equation, which is what we're looking for. Okay? So I need to find the derivative with respect to x of both sides. So 4x squared minus y cubed is equal to the derivative with respect to x, negative 11. So take the derivative of both sides, set equal to each other, find out how these rates are related. Derivative of any constant is 0. So that's a nice, easy derivative to calculate. And again, like I like to coach, if you're feeling comfortable and you can look at the derivative of 4x squared minus y cubed and calculate it as is, you are more than welcome to, or you can make the observation that I can split that derivative over that minus sign and then look at them individually. Okay? So then the derivative of 4x squared, well, bring the exponent down, multiply by it, and subtract 1 from it. So it'll give me an 8x. And then I got to figure out, okay, well, what is going to be the derivative with respect to x of y cubed? And the entire thing that we've been doing with implicit differentiation or related rates problems is you take the derivative as if you're taking the derivative with respect to y. So bring the exponent down, subtract 1 from it, but then chain rule, because this is not x, chain rule says I need to multiply by the derivative of y, that dy over dx. So the derivative of y cubed will be 3y squared dy dx. Then from there, I've done all the calculus. Now I just need to do my algebra. Solve for dy over dx, and then plug in the 2 values for x and y. Technically, you could plug in the values for x and y here and solve for dy over dx. It doesn't really matter. But just so some of y'all see that you got the correct implicit equation, or the correct equation for the derivative, dy over dx. Sorry, I said implicit equation. Subtract 8x from both sides, and then divide by a negative 3y squared. Well, those negatives will cancel each other out. I'll be left with an 8x divided by 3y squared.
I have a question.
Yeah, what's up?
Isn't it going to be positives for the 3y squared?
It is.
So it should still have the negative.
Well, no, because let me write it out. I'm taking a negative 8x, and I'm going to be dividing it by negative 3y squared. And so in the top I have a negative, the bottom I have a negative. The negatives cancel each other out and leaves me with a 1.
Dang. Okay. Thank you.
Yeah. Thank you for asking. Glad I can clarify. My volume started raining really loud here. So that is my equation. Now plug in my value of x and y. So then at this point, whoops, did I hear a question? Okay. So dy over dx would be equal to 8 times 2 over 3 times 3 squared. 8 times 2 is 16, 3 squared is 9, and 3 times 9 is 27. So your final answer would have been 16 over 27. How y is changing as x changes at the point 2, 3. When x is 2, y is 3. Well, this function is changing at 16 over 27. Okay. So, questions? If not, give me a thumbs up like usual.
Just for clarification, so when we're finding the dy divided by the dx, we're finding the value itself, not just the equation that we would use.
Well, it depends on what you're being asked, right?
Oh.
Does it say just find dy dx here?
Mm-hmm.
The answer
No.
It was find dy dx when.
The values. Okay. Gotcha.
So that's why I wanted to make sure I went through it, because at least I know a couple people put in this as their answer, which is not what I was asking, but that is 100% correct spot along the process, right? You did the differentiation correctly. Really all you missed was just plugging in the values. Yep, awesome. Any other questions? Yeah, some people are giving me thumbs up saying they're good. All right, so we're going to move on. And today is going to be talking about the derivative of our exponential and logarithmic functions. Again, you should have watched the videos. They give you a couple examples, and we're going to be doing more examples today. But let's talk about what these derivatives are real quick. We have two basic ones, and then from that, we also have the derivative of 8x. I don't have enough room, so I'm going to come down or come over here. Derivative with respect to x of log base a of x. Hey, so the derivative of e to the x is probably one of the easiest derivatives to remember. What is the derivative of e to the x? Someone please unmute themselves and tell us.
E to the x.
E to x.
Yeah.
Just
Ooh, yeah, symphony of answers. I love it. Right? Yeah, this is the easiest one. It is its own derivative. E to the x is its own derivative. The derivative of e to the x is e to the x. Okay, what about the derivative of the natural log of x?
is that 1 over x or something?
Divided by x.
Yeah, got 3 answers here. All correct. 1 over x. And don't worry, I asked that and I expect y'all to be talking over each other and I'm going to just hear the answer. Okay, so don't worry about talking over each other. That's what I'm expecting. So those were the two basic ones. We have derivative of e dx and derivative of natural log of x, but those are a specific exponential function because e is a nice value, that natural number, and natural log of x is log base e of x. So I have these derivatives, but whenever I'm using a different base, and that's why we use this a right here, assuming that this is got to be some number greater than 0. And also we're just considering it not being 1. But the derivative of a to the x, it looks similar to e to the x. Exponential functions, the derivative of any exponential function is whatever that exponential function is, but I need to multiply it by the natural log of whatever the base is. Okay? And if I apply this formula right here to the derivative of e to the x, say, okay, well, these should match up because e to the x is one of these different things. This would mean that this is natural log of e times e to the x, and I have to make you remember this. Let's see who does. What is the natural log of E?
Not just one or something?
Yeah,
Wait,
it's
no.
just the
What
one.
is?
Which means I'm just multiplying it by 1, and that's how we get, really, that specific example. The derivative of e to the x is e to the x. It's still following this formula. We just are able to calculate that natural log of e, and we know it's going to be a 1. So anytime I take the derivative of an exponential function, I take the natural log of whatever the base is, and then multiply that by the original exponential function. And natural log is kind of similar. Again, we see this natural log appear, or log base a, sorry, the derivative of any log. So log base anything is going to have a similar feel to it. We're going to see this natural log of a appear. And the answer, let's see if I can fit it in here well, is by taking the natural log of whatever your base is, putting the denominator, multiplying it by the x. So again, it looks like the natural log of x, that derivative. We see that 1 over x, but I just have to make sure I again multiply by the natural log of whatever the base of my log is. I know in the video he goes through why that natural log shows up. It comes from change of base by using this natural log of x. But again, let's just say we blindly follow the general case. Natural log is log base e of x, which means if I follow this formula up here, it'd be 1 over the natural log of e, not 3, times x. And we just said the natural log of e is 1, so I'm multiplying that x in the denominator by 1, and that's how I get 1 over x. So these are related. The first two that we see are just specific cases. We still like to list them out on their own because they're functions that we see a lot, especially in applications. When you get into biology, you talk about exponential growth, chemistry, exponential growth, logarithmic growth, things like that. And most of the times it is determined by that value e, the natural number. Right? So that's part of the reason why we separate these as kind of their own two derivatives. But really, they're always just following our general derivative formulas for any exponential function or any logarithmic function. So that's where those derivatives come from, and we are going to practice them. So let me get the activity up. So you've got a new question, and I at least made it a little bit easier this time because I'm going to let you select the answer versus typing it in. Now, I think this is the only one I give with multiple choice. So let me put it up on Poll Everywhere. I'll give you all a second to finish writing it down, but you can go ahead and look at Poll Everywhere and see the question. It is the derivative of 3 to the x plus e to the x. Derivative of 3 to the x plus e to the x. So I want to calculate this derivative. Oh, Dezante, I just saw your message in chat. Yeah, you got to remember that y squared there for the daily quiz. All right, so there it is. We get it in the recording now, which the following is the derivative with respect to x of 3 to the x plus e to the x. Responses. All right. We got 9 people in, which is good. I'm going to give you all just one more minute for the sake of time so we can make sure we're getting through examples. I want to try to give you all breadth of practice here in this session. So I'm just going to give you all one more minute to select your answer. Worst case, give me a best guess. So 11:19. So I'm going to lock answers. All right, just to give you a heads up, you now have 20 seconds to select your answer. Just a heads up. 20 seconds. I know it's a little rushed, but at least you don't have to type it in this time. I'm locking answers in 5, 3, 2, 1. Should have 23. We're missing 3 people, but locking answers now. All right, we got 2 of the 3 people that answered the last second. So 77% of y'all got it correct, which is good. Hopefully you didn't guess. Hopefully you did the calculation. But it is that second choice, natural log of 3 times 3 to the x plus e to the x. So we're calculating this derivative of 3 to the x plus e to the x. And I see this as the sum of 2 functions, so I can split that derivative, whether it's in my head or on paper, I can split that derivative up over that plus sign. So this is a derivative of 3 to the x plus the derivative of e to the x. And one of those two is a little bit easier than the other because it's what we talked about. It's a nice special derivative. And what is the derivative of e to the x?
E to the x.
Yeah, derivative of e to the x is e to the x. It is its own derivative. So the derivative of e to the x, let me underline it in blue. So we know where it's coming from. That's that calculation. Now I got to figure out what is the derivative of 3 to the x. Well, we said the rule, the derivative rule for any exponential function where a is a number and you have your exponent is your variable. This is the natural log of a times that exponential function. So in this case, my base is a 3. That means the derivative of 3 to the x is going to be, whoops, not blue, natural log of 3 times 3 to the x. So that is the correct derivative for this one. Okay. Questions so far? If not, give me a thumbs up. Same process we've always been doing. So you got some people came late. There's that Poll Everywhere link just in case. Cool, cool, cool. I'm seeing thumbs up and not hearing anything. All right. So next question is now up. This time, again, I'm giving you a multiple choice, giving you options to choose from. So I'm going to share the Zoom screen so we get it for the recording right now. So that whiteboard's going to go away. But you can go ahead and go to Poll Everywhere. I want you to differentiate the function f of x, which is log base 8 of x squared plus 1. Differentiate log base 8 of x squared plus 1. So I see something in chat. Cool. Cool. Thank you both, because there's 2 people having issues with the internet a second ago. Thank you for sending that message. Thanks for letting me know. All right. Hopefully you can get back, see it. So we got most people answered. Let me give you all just 30 more seconds, again, for sake of time. I'll say a minute. So it'll be technically 11:24 with 30 seconds. But I'll give you just under a minute now. Finish doing your work and select your answer. We got most responses in 20 seconds until I'm locking answers. Just your heads up, 20 seconds. All right, I'm going to lock responses here in 5, 3, 2, 1. Locking answers now. All right, so interesting spread of responses. There's not a clear leader in the choice. What y'all think is correct? Let's talk about it. I'm trying to find the derivative with respect to x of log base 8 of, was it x squared plus 1? I even forgot for a second. Yeah, x squared plus 1. I can write an 8. All right. So when I take the derivative of this, yes, I know I'm going to have to take the derivative of a log function because I see a log function there. But that's not the only thing that I see. I don't only see a log function. What else do I see inside of there?
Product.
Not product. What is inside of that log function?
X squared plus 1.
X squared plus 1. And that key word that even when we just said it, we said inside. Right? That is a function inside of another function, which means what derivative rule will I have to use?
The chain rule thing.
Yeah, chain rule. And again, there's supposed to be a cacophony of people answering. That's fine. Don't worry about talking to each other. I got to use chain rule. So I have to identify, okay, what is my outer function? What is my inner function? Well, similar with some trigs, it's a little bit easier to spot outer and inner with logs. So if I just kind of write my chain rule again down here, take the derivative of the outer, keep the inner, but then multiply by the derivative of what was inside. So if I look at log base 8 of x squared plus 1, my outer function would be log base 8, and my inner function is that x squared plus 1. So I need to figure out, okay, what is the derivative of log base 8 and then the derivative of x squared plus 1? Well, one of those is a little bit easier. That's the derivative of x squared plus 1. And what's the derivative of x squared plus 1 going to be?
2x.
Yeah, 2x. Now, the derivative of log base 8 of x also isn't too hard of one to calculate. We're just not as familiar with it. But what is it going to be? Derivative of log base 8 of x. What is it going to be?
ln of
We'll say let Josh go, Bizante. I haven't heard Josh speaking here in a while.
going to be ln of 8.
So there is an ln of 8. It's part of it. Anyone else can help him out? Bizante, maybe?
Is it 1 divided by x ln 8?
Yeah. X ln of 8 or ln of 8x. And just because natural log of 8 is a constant, right? It's a weird constant, it's a rational number, but it is a number. So there's usually this idea of we like to kind of put our constants out front. So natural log of 8 is usually the way I write it, but if you wrote x natural log of 8, you're 100% correct as well. Okay. So that is the derivative of my outer function and then my inner function, which means when I take my derivative of the outer function, I plug back in the inner function, where I see myself plugging stuff back in is down there in the denominator. What the derivative of f of x is telling me is I'm going to take 1, divide it by natural log of 8 times whatever you give me. So the overall derivative, the derivative of log base 8 of x squared plus 1 is the derivative of the outer function with the inner function plugged back in. So it's 1 natural log of 8, but my inner function was at x squared plus 1. And that's what my function down here tells me to do, right? I'm going to take 1, divide it by natural log of 8 times whatever you've given me. I got to plug back in my inner function, x squared plus 1, so that's where it appears. But then I need to multiply by the derivative of my inner function, derivative of x squared plus 1, which is my 2x. And if we just clean this up a little bit, this will always be 2x, or this not will always be, this will be 2x divided by natural log of 8 times x squared plus 1. That actually be that first answer. So chain rule pops up, especially with all of these types of functions. Natural log function, exponential functions, chain rule, product rule, quotient rule are just going to show up. We're just adding new derivatives to our repertoire. All right. Gotcha, Shamika. Thank you for telling me. And so, same drill. Questions if you got them. Thumbs up if you're good. Just, I guess, while I'm waiting for an answer, that second choice, the 1 over natural log of 8 times x squared plus 1, that was kind of the trick to see if you're doing your chain rule. I just want to point that out because that was the second most popular answer. Always got to make sure you can spot the composition. You got to multiply by the derivative of the inside. But sorry, I didn't give you all just a second. Questions, if you got them. I'll give you a few seconds. Cool.
I'm kind of
All right.
confused
Sam. Mm-hmm.
on how you got 1 over natural log of 8 times x squared plus 1 when you combine f prime and g of x.
So we're trying to do here, I'll write it in blue right here. F prime at g of x, right? My rule for f prime says, whoops, I'm trying to erase. Whatever you give me, right? Whatever you plug into this derivative, it's 1 divided by the natural log of 8 times whatever you give it.
Oh, okay, okay. I get it now. I get it now.
Perfect. No, I'm glad I could clarify that.
Thank you.
Yeah. Thank you for asking and not just sitting there and suffering in silence. I hate it when people do that. All right. So you're going to have another question. So now you're going to have to start typing your answers in. Now you're going to have to start typing your answers in, but this is another one, another chain rule that we're going to see a lot. Differentiate the function f of x, which is e to the x cubed minus 2x plus 1. E to the x cubed minus 2x plus 1. I'm going to give you all, again, just till 11:35, which is just under 2 minutes. I know it's not a ton of time, especially for when I'm asking you to type in your answer. So at least get to a final answer. If you get the time, type it in for me, please. So I just want to make sure we're doing more examples, okay? All right. Like I said, I know it's not a lot of time, but 1 minute left. 1 minute left. All right. Glad I asked this one. All right, so I have 11:35. Go ahead, if you're typing something in, finish it up. But we're going to go ahead and work on it. So I'm going to lock answers here in 5, 3, 2, 1. Locking answers now. So again, we have a chain rule that is going to have to happen because this function is e to the, we've got a new function, x cubed minus 2x plus 1. So again, I'm going to have a chain rule, and I do have an outer function and an inner function. My question for y'all is, what is the outer function?
E? I didn't know that what the function was.
Yeah. Outer function is e to the x. Because then what am I plugging into the exponent of e? Well, x cubed minus 2x plus 1. So this is a chain rule as well. I do see a composition of functions here. It might not have been obvious at first, but hopefully now after we point it out, you do see what you're doing is you're taking that g of x, plugging it into e of x, plugging it into the exponent of your e. Which means I got to apply chain rule here, and I got to find the derivative of my outer and my inner functions, and then plug them back in the way chain rule tells me. Derivative of the outer times, or plug back in the inner, and multiply by the derivative of the inner. But derivative of e to the x is always what?
E to the x.
Yeah, e to the x. So my outer function won't change. What is the derivative of g to the x? Well, this is something I trust y'all can do. We're getting really familiar with polynomials now. This will be 3x squared minus 2. Essentially applying the power rule to the first two and then the constant rule to the last part of that polynomial. Okay, so then when I go to get my chain rule, the derivative of the outer, plug back in the inner, well, it's still going to be e to the x cubed minus 2x plus 1. E to the x cubed minus 2x plus 1. But then that was the derivative of the outer function with my inner function plugged back in. I need to make sure I multiply by the derivative of the inner function. So you'll see it written as, the answer should be e to the x cubed minus 2x plus 1 times 3x squared minus 2x. But one way we like to rewrite this, just to kind of make sure we don't have any overhang of that exponent and then what we're multiplying after, just pull it out front. So this last step is just about rewriting it to make it look nicer and easier to read. What becomes, the derivative is 3 to the x squared minus 2 times e to the x cubed plus, or minus 2x plus 1. Okay. In fact, in general, there's a nice little shortcut. Anytime, because of my chain rule, anytime I have e to some function of x, I don't care what that function of x is, just some function of x, the derivative will always be the derivative of the exponent times e to that function of x. And that's what we see here. It's a nice little shortcut. Sometimes it's told. It's one of those, it comes from chain rule. So sometimes you're given it explicitly, sometimes you're not. But there it is. Okay, so again, questions. Questions, questions, questions. If not, give me a thumbs up. Thank you, Justice. I saw that. See from the other people. Yep. Cool, cool, cool. All right, last call for questions. All right, so you're going to get a new question on poll everywhere. Again, you're going to have to type it in, but this time I want y'all to go to, no, we're not going to go to breakout rooms because I want to try to get one more example in. I want to save time transitioning. So this one, just keep it in, we're just going to stay here in Zoom, work on it on your own, and type in your answer. But we're looking for, in this case, the derivative. I'm going to share screen, so you're about to lose the whiteboard. Sorry. But we want to differentiate this function, f of x, which is cosine of x divided by the natural log of x. Cosine of x divided by the natural log of x. I want to find this derivative. Find this derivative. All right, I'm going to give you all 3 more minutes because I know this one is a little bit to type in, so I want to give you all some time to do that. But at 11:45, we're going to come back to Zoom once you're done. No, we're still waiting for responses. All right, we have, let's see, we have 1:40 left. 1:40 left. Overall, looking like got good responses so far. All right, definitely good responses coming in. You got 1 minute left. 1 minute left. All right. Sorry, I'm looking at some of the answers. All righty. So 20 seconds. Got most people in, just missing a few. Like I said, I know it's a lot to type in. I'm going to lock answers here in 5, 3, 2, 1. Locking answers now. So most of y'all did spot the derivative rule that you have to use, because I have cosine of x divided by natural log of x. And anytime I have the division of two functions and I'm taking the derivative of that, what rule do I have to use?
Quotient.
Quotient rule. Yeah. So I'm going to have low d high. So natural log of x times the derivative of cosine of x. Derivative of the top times the bottom is another way. Minus high d low. What's on top times the derivative of what is on bottom. All over what was on bottom squared. So all I need to do now is figure out, okay, what is the derivative of cosine of x and the derivative of natural log of x, and fill them in. Well, so this first term will be natural log of x times negative sine of x. The derivative of cosine is negative sine. And then I'm going to be subtracting cosine of x times the derivative of natural log of x. And what did we say the derivative of natural log of x is?
1 divided by x.
Yeah, thank you. 1 divided by x. That derivative 1 over x is coming from the derivative of the natural log of x. So now I've done all the calculus. If I want to, especially because I got to think about I need to type this in to web work. I might want to have less to write as my final answer, etc. So I can clean this up a little bit. So not too much. It's more about how it's written. But I have a negative sine of x times natural log of x minus, you could write this as a cosine of x over x if you wanted to. You could leave it as a cosine of x times 1 over x. It's just another way to write it. It's what I have here. And then at the bottom still I have natural log of x squared. That last quality is just rewriting, trying to clean it up a little bit, make it look a little bit nicer and easier to read. But again, I always like to say right here is where the calculus stopped. Right? You've calculated all of your derivatives. So same question or same thing. Questions if you got them? Thumbs up if you're feeling good. Ready to move on. All right. So I won't have time for the last derivative that I wanted to for y'all to calculate, put it up and pull everywhere, let y'all kind of work on it for a little bit and see how we're doing. So we're just going to do it here in Zoom for the last couple minutes. I'm just going to walk us through it. So I have the natural log of tangent of x. What derivative rule will I have to use here?
Chain rule.
Yeah, chain rule. Perfect. Right, because I see I have a function inside of a function. I have my tangent function inside of that natural log function. So I can identify what my outer function is, which is the natural log of x. I have my inner function, which is tangent of x. And just for brevity, because we're running out of time, those derivatives, natural log of x is 1 over x, and the derivative of tangent of x is secant squared of x. So when I take this derivative, I take the derivative of my outer part, the natural log function, but plug back in what was inside. So this would be 1 over the tangent of x, because what the derivative of natural log tells me is I'm going to take whatever you give me, put it under a 1, divide it into a 1. But then I need to multiply by the derivative of my inner function, the derivative of tangent, which is secant squared of x. And just combining them together, this gives me secant squared of x divided by tangent of x. So again, that second equality is just a rewriting. All the calculus was done after that first equality. We calculated our derivative using the derivative rules and got the correct parts, derivative parts. Okay, you could simplify that further if you wanted to rewrite secant squared as 1 over cosine and tangent over sine over cosine to see how it simplifies. You're more than welcome to, but that's just more algebra skills than calculus. Okay. And this also gives me a nice little formula for the natural log function. Anytime I have the natural log of some function of x, it's always because of chain rule, which is the most important rule that a lot of people dislike, but it is the most important thing. As we see here, the derivative, the outcome will always just be the derivative of what is inside divided by what was inside. Because the derivative of your natural log function is just 1 over what was inside. So that's why the f of x appears in the denominator. And then you multiply by the derivative of what's inside, and multiplying by a fraction just means throw it up into the numerator. Okay, so that's a nice little shortcut for those types of derivatives. So, thumbs up if you're feeling good. Questions if you got them. Block that off too.
So whenever we see something in that format, we can just find the derivative of what's in, of like what's here and just put it over.
Mm-hmm.
Okay, that's fine. Thank you.
This will always be a nice, dependable form. I think even I believe the textbook, maybe I read another source, but I believe the textbook goes through the proof on that, but it's just chain rule. All right. Any other questions? All right, y'all are good to go. If you want to stick around for a second and wait for some people to leave and ask questions, you're more than welcome to, but I'm going to go ahead and stop the recording now.